Hi students, after a long time we came back. So I left the topic for you people, meter bridge and potentiometer. So today we are going to discuss about meter bridge. If time is available, we will see potentiometer also. So after a long time, again we are coming back to PU classes. Okay, up to now you saw competitive classes. Once again we will start PU. So our pending topic, meter bridge and potentiometer in current electricity lesson. Where we stopped means after completion of meter bridge, Wheatstone bridge. After completion of Wheatstone bridge, we stop. Now again we are going to start meter bridge and potentiometer. Why I am saying Wheatstone bridge means Wheatstone bridge condition we are going to use in meter bridge. So for this meter bridge we are going to give what is the construction, so what is the use, what is the theory and what is the practical, how we will do, both will be same. In practical also you will do meter bridge and potentiometer. So I am going to show you how is the meter bridge. See here, so this is nothing but meter bridge here. So you will be standing this side, but I stood opposite to yours, isn't it? If you are standing here, if you observe this one, sorry, like this. So you will be standing here. Okay, you will be observing from here, but I am explaining from this side. You can see once, here one wire is there. Okay, so length of this wire, see here, this wire, you are able to see anything, see. I am oscillating this one. This is one wire. This length of the wire is almost 100 centimeters. That is nothing but 1 meter. So length of this wire is 1 meter. Therefore, we are calling it as meter bridge. I am going to draw this one on the board later. Now first we will see what is the construction. So 1 meter wire is there on the wooden scale. See here. So 1 meter means 100 centimeters. And this is connected by one metal strip here, L shape. This is another one. Okay, two L shaped metal strips, and here we are getting two gaps. See, in this there is no metallic strip. Here also there is no metallic strip, but here again another metallic strip is there. This is made of copper to flow current easily. Okay, so this gap we are calling it as left gap. This gap we are calling it as right gap. I am saying for you it is left gap, but for me it is right gap. But always you will be standing from this side, therefore right is going to become left. But for you it is left gap, this is called right gap. So what is the use of this one? So we will find unknown resistance of the given wire or given conductor. How we will find? How we will find means we will connect resistance unknown wire here, either in left gap or right gap. If you connect in left gap unknown wire, right gap what we will connect we will see. So one wire if you brought, we connect that one in the left gap. This is nothing but this resistance of this wire we have to find. Now in right gap what we connect means known resistance we will connect. Okay, how we will connect I will explain for you, just I am showing. And in this black one is there, this is nothing but we are calling it as jockey. Okay, with sharp edge it will be there. This is also another conductor. So with sharp edge, this is called jockey. J we will write on the diagram. So this is left gap, this is right gap. In left gap what we connected, which resistance we are going to find. In right gap we connected known resistance. And here one screw is there, you see. Here another screw is there. Between these two screws we are going to send the current. How we will send means by connecting the battery. This one we are going to, I am going to draw on the board once you can see clearly. This is L shaped strip, metal strip. This is another L shaped metal strip. This is called left gap, this is called right gap. So from here I am going to show for you as points A, B, C like that. Once again I will show after drawing on the board. This is nothing but meter bridge.
Right.
Now we are going to see what is the principle and what are the uses of meter bridge and construction and working of the meter bridge. Okay, first what is the principle? If anyone asks what is meter bridge means, if you remember principle, you can say the definition of meter bridge. So what is the principle of meter bridge? You know already, Wheatstone bridge. Wheatstone bridge. So what we want on Wheatstone bridge means balancing condition. The balancing condition of Wheatstone bridge is only nothing but principle of the meter bridge. If anyone asks you, for this no definition will be there. If anyone asks you what is meter bridge, meter bridge is a device which is working on the principle of Wheatstone bridge. What is the Wheatstone bridge? Formula, balancing condition you came to know, P by Q is equal to R by S. What are P, Q, R is there? Resistors. 4 resistors are connected in the form of bridge shape. Like rhombus, we will connect. Already you came to know about this one. This is the principle of Wheatstone bridge. Now what are the uses? What you are going to find by using meter bridge? Where you are going to use the meter bridge means, already first one I told for you to find. What we are going to find means to find unknown resistance of the given wire. Wire means here you can bring any copper wire or iron wire, steel wire, some amount of length you can take. I told you already that wire, if you connect in left gap of the meter bridge, we can find the resistance of the given wire by using meter bridge. Second one, to find specific resistance or resistivity. So resistivity of the given wire. Same wire, resistivity also we can find. Once we came to know resistance, we can find the resistivity of the given material. Already you came to know this formula in current electricity I gave. R is equal to rho L by A. This is the formula for resistivity and resistance relation. If you know resistance and length, area of cross section, we can find resistivity. That is nothing but rho is equal to RA by L. How we are going to find? I will explain for you. Now, if they are asking for 2 marks question, what are the uses of meter bridge? If they ask me, you can write to find the unknown resistance of the given wire, to find the resistivity of the given material of the wire or given wire. Next, what is the construction and what is the working? I told you, I have shown for you meter bridge, that one only. How it is going to be constructed, I will show according to diagram. In that meter bridge, 2 L-shaped metal strips are there, isn't it? So this is one L-shaped metal strip, another one another L-shaped metal strip. All these metal strips they arrange on wooden pole in the meter bridge. So this point, let us assume a screws will be there. I think already we have seen those screws. So this is A, this is B. This one we are calling it as left gap, this one we are calling it as right gap. On this one, wooden scale will be there. Length of this one is 100 centimeters. On that, one wire will be there. So wire length is 1 meter. Therefore, this one we are calling it as meter bridge. So this wire is made up of. They may ask me one more question. This wire is made up of manganese or constant. Why? Because its resistivity value or resistance value will not change with rise of temperature. Why? Because whenever current is passing, this temperature is going to increase. Heat it will become. Therefore, to not to change resistance value, they will use manganese or constant. Okay. So this one we are calling it as left gap. This one we are calling it as right gap. In this, I did draw this wooden board. As it is, I have drawn what is the measurement. You can see it. Okay. So this is scale. This is scale. On this one wire is there. See, I am showing here. Don't play like this in lab. And this is one L-shaped metal strip. This is one L-shaped metal strip. This is center. So this screw is I am drawing here. This is left gap. This is right gap. Now, how you will send the current? How you will send the current for this one means what we are going to use? One battery. So to provide this one, we will use one key. Key means to break or to make the circuit. If you remove the key, so you are breaking the circuit. Like that is nothing but switch off, switch on. So suddenly we can't connect switch for this, therefore we will use key. Already you came to know in your 10th class what is the purpose of the key. And again, this one I am connecting to point. If you press the key here, this dot indicates we are closing the key. Whenever we are closing the key, what is going to happen means some amount of current is passing through this wire and this current is passing through metal strip up to here. It is nothing but broken. It is also broken. Now, this is nothing but construction. Okay. Now this central, I am going to connect for one wire through what is there here? I have shown for you already. The center one will be connected for jockey. How it is connected means through galvanometer. This is one galvanometer. It is connected by the jockey J. In diagram jockey J they have shown means it is nothing but jockey. It is denoted by J through galvanometer. What is the purpose of galvanometer means whether current is flowing or not, we will be finding by using galvanometer. Not to measure whether current is flowing within the circuit or not, we are going to use galvanometer to detect the current, not how much current is passing. Okay, this is nothing but construction. And again, we are finding first unknown resistance. That unknown resistance wire we should connect in left hand. That wire I am drawing like this. This resistance value we have to, that is X. X is the resistance of the given wire. You can take any wire, some amount of length. That wire we have to connect between the two screws. How they will connect? They will show in the lab. You will also do the same experiment. And in right side, they will use one resistance box. Resistance box means we will apply known resistance, that is nothing but 1 ohm, 2 ohm, 3 ohm. How much resistance we are applying, we will be coming to know in the right gap. Okay, so this galvanometer they will show in some books from here only. To not to make you confused, I have drawn here outside. What does this indicate means these wires are not in contact, these wires are one on above, these wires are not in contact. This one is going to indicate. Okay, this is nothing but construction of the meter gauge to find unknown resistance or to find resistivity of the given material. Whatever they are asking, this is nothing but construction. Once again, we will see A and B we connected for battery with a key. Why we connected battery means to provide the current. Okay. Next, left gap unknown resistance why we connected. In right gap known resistance. That is nothing but resistance box we connected. Resistance box we connected means known resistance we connected. Remaining from center through galvanometer we connected for jockey J. This is nothing but construction of the meter. Now we will see what is the working, how it is going to work. After all these connections, you have to check whether connections are wrong or right. How we will check means if you keep this jockey. So this jockey J at left corner. Then in this galvanometer you will get right side deflection. So galvanometer will be like this. The needle will be there here. If you keep here left, it will move towards right. Okay. If you keep at B, then this needle will come towards left. If you keep left side, galvanometer will show deflection towards right. If you keep right side, galvanometer will show deflection leftwards, opposite sides. Then your connections are correct. If it is not showing like that, somewhere you will be able to use connection, you have to make it tight, then it will be coming definitely. Okay, this is nothing but how to check whether connections are correct or not. Now what is the working? After getting all these connections, what you should do means very simple one. You have to move this jockey on this wire like this. On this wire unless we are getting galvanometer deflection is 0. Why galvanometer deflection should be 0 means what is the principle we said? Wheatstone-Ridge principle. In Wheatstone-Ridge principle, whenever the current passing through galvanometer is 0, that is nothing but Ig is equal to 0, then we are saying bridge is said to be balanced. Therefore, the current which is flowing through galvanometer should be 0. How it is going to be 0? How it is equal to Wheatstone bridge? Just same diagram. It is equal to Wheatstone bridge. I am going to draw. Once we will see. Let us say this is point C, where we are getting point B, null reflection. That one we will say. First, whether it is in Wheatstone bridge or not, we will say. You move this jockey on this side. Somewhere you got deflection 0. That is nothing but D. Now this jockey is on D. Now how it is equivalent to Wheatstone bridge? Just I am going to draw. In left gap what is there? Unknown resistance. In right gap what is there? Known resistance. In between these two, one point C is there. So this left gap resistance. This is nothing but X. This is starting from A. Ending at let us assume C. So from C, another one resistance box in right gap. How these two are connected? This left gap and right gap both are connected in series. So this is in resistance. This is connected for B. Okay. Next, A to D. This is nothing but some amount of length. Let us assume L. Next D to B. This is another amount of length, that is nothing but 100 minus L centimeter. In some books they will write this is L1, remaining is L2. Both will be same one. Okay. Now A to D. What is there here? D to B. So A to D what is there means L. D to B what is there means 100 minus L. Between C and D what is there? Galvanometer. Now is it Wheatstone bridge or not? We will check. Again between A and B what is there? Battery is connected. Battery is connected with B. So if you forgot, once you can recall this one, this is equivalent to Wheatstone bridge. At that time we have written this is P, Q, R, S. But okay, P and Q resistances are there. Then how these AD and DB will be resistances? So already you came to know resistance is directly proportional to length. This Y from A to D will be having some amount of resistance. Therefore, this is also having some amount of resistance. This resistance is directly proportional to length. Therefore, it is also having resistance. DB also having resistance. When this balancing condition will be coming, the amount of current flowing through the galvanometer is 0. Therefore, we should move the jockey on the Y unless and until galvanometer shows null deflection. Null deflection means on this galvanometer 0 will be here. Whenever we are moving, this galvanometer needle will come to 0. Whenever it is coming to 0, then current flowing to galvanometer is 0. Whenever current flowing to galvanometer is 0, then what we are saying? Bridge is said to be balanced. Whenever bridge is said to be balanced, PQ, RS. What is the condition? P by Q is equal to R by S. In place of P, what is there here? X. In place of Q, what is there here? Known resistance. R. In place of R, what is there here? L. So L by 100 minus L. If you are taken L1 and L2, L1 by L2, both will be same one. So this is nothing but already we came to know L1 and L2. Why? Because whenever we are moving jockey on this Y, somewhere it will show null deflection in the galvanometer. Where it is showing null deflection? From here to here. That is nothing but length. Let us assume some 40 centimeters you got. If it is 40, remaining length is how much means 100 minus 40. That is nothing but 60 centimeters. So this L1 and L2 you will be coming to know how much resistance we kept in the right gap we came to know. Therefore, three known factors you came to know. This is unknown. Therefore, you can find this X value. X is equal to R into L by 100 minus L. Now what is X here? Unknown resistance of the given Y. So we will keep here in lab. How we will do means we will connect one wire here. In right gap we will keep 1 ohm. For 1 ohm, where we are getting balancing length, we have to find. Next, we will give same thing here. In right gap we will give 2 ohms. For 2 ohms again we will give find the null point. Null point means here where resultant deflection within the galvanometer is going to be 0. This process will be continuous. In this you have to remember only one word, move the jockey on the wire. Move the jockey on the wire unless and until you are getting null deflection. Otherwise move the jockey on the wire till you got the null deflection in the galvanometer. Okay, so then that length is said to be balancing length of the meter bridge. Balancing length means here, if you are getting a point in null deflection from A to D is called balancing length of the meter bridge. This is nothing but unknown resistance. How to find? This is nothing but working of meter bridge. This is nothing but previous one, construction. Here, in this equation I wrote P by Q equal to R by S. This R is not coming here. I am saying Q value we have taken some amount of value that is denoted by R. Okay, don't get confused with this R and this R. Here X is in place of P, X unknown resistance. In place of Q, known resistance. This value you came to know. Okay, known resistance R. Don't confuse the equation. Actually, you won't write here, directly you will write in exam this one. Here R is nothing but Q is nothing but R. This R is nothing but L. In place of S, what is there? 100 minus L. So in place of R, L is there. I have drawn here P, Q, R, S to recall Wheatstone bridge. You should not write this one in exam, in your notes also. Okay, don't write this P, Q, R, S. Just I am recalling the Wheatstone bridge diagram. Okay, this P, Q, R, S you should not write in exam. Only have to write X by R is equal to L by 100 minus L. This one we found unknown resistance of the given Y by using meter bridge. This is one of the use. Now we will see next use. See our next use. What is the next use? We said to find the resistivity or specific resistance of the given material of the wire. If you have taken one copper wire, what is the copper resistivity? If you have taken a steel wire, what is the steel wire resistivity? How you find means already we found resistance of this given wire. Once you came to know resistance of the given wire, very easily you can find resistivity. So what is the resistivity formula? So we know that rho is equal to RA by L. Where L is length of wire, length of the given wire, or what you have taken that wire length. Another one, A. What is area? Capital area of cross section. Area of cross section of the given wire. What is the formula for area of cross section? A is equal to pi r square. What is r here? R is nothing but radius of the given wire. So how you will find radius of the given wire means in first period you came to know how to use screw gauge. By using screw gauge you will find radius of the given wire. In your lab exam, if this one you got me, this radius value they will only give. External only will give. You have to simply substitute that. So A is nothing but pi r square. L is nothing but length of the given wire. How to find length means you have to give the wire on the meter bridge. It will give the length. Next, what is this R? R is the very important one. R is the resistance of given wire. What we found by using meter bridge means this R only we found. What is this R means? See, above it is there. X is equal to RL by 100 minus L. So you will get this value by using meter bridge. You have to substitute this X value. Means R is equal to X. R is equal to X and A is equal to pi r square. L is nothing but length of the given Y. You have to substitute all these values in this equation number 1. Substitute R value equal to X. Substitute A is equal to pi r square. Substitute L length. Then you will get rho is nothing but how much value. But while substituting, you have to take the units very well. While finding length, you will find in centimeters. But you should convert it into meters, centimeters to meters. While finding radius, you will get by using screw gauge in millimeters. You have to convert radius millimeters to meters. Already you calculated resistance in ohms. Therefore, directly in ohms, we will substitute. What is the unit of resistivity? Ohm meter. Units also very important while writing. This is nothing but again same process. How you will find means first we will find resistance of the given wire. Later you will substitute this resistance value in the given equation. Okay, this diagram I told you in other way also they will draw this galvanometer, they will show in between. Whenever you are showing like that, how it will become? Just I will show, we can see one. So this one they will start from here. Here they will show galvanometer. This one only they will change. They will write jockey J. Both will be same one. So once you go for lab, if you do this experiment, it will become very easy for you. Without reading only you can remember. Why? Because already you read, you are going to do practical. You will do this one in lab. Therefore you can remember very well. So but how to frame the sentences you have to see. In this only one word, move the jockey on the wire till you got the null deflection in the galvanometer. That one if you remember me, you can frame the sentences according to your own wish. Okay. So see, now we are going to discuss one problem on meter bridge. So this is, in the problem they have given two unknown resistances. One is in left gap, another one is in right gap. In left gap resistance is P. In right gap resistance is S. When two unknown resistances are connected in left gap and right gap, balancing length of the bridge is nothing but 20 centimeters. In left gap what they connected? P. In right gap what they connected? S. Two unknown resistances are connected in left gap and right gap. Now the balancing length of the galvanometer, whenever we are moving the jockey on the wire, balancing length they gave 20 centimeters. Next, in the problem, now in the right gap for S, a 10 ohm resistance is connected in parallel. So how they connected? 10 ohm resistance is connected in parallel. Then balancing length of the meter bridge is 50 centimeters. This is nothing but given problem. In matter way they will give, just I have drawn here diagrams. Okay. In first case, two unknown resistances they connected in left gap and right gap. Balancing length is 20 centimeters. In second case, for right gap resistance they connected 10 ohm resistance in parallel. See how these two are connected in parallel. Then the balancing length is 50 centimeters. Then what is P value and S value? You have to find P value and you have to find S value. Okay. This is nothing but what you have to find. Whenever they get problem, always you will write given that. Okay. Here two cases are there. In first case, in case 1, what they gave? P value, S value they said. P value we should find, S value we should find. These two they said. Next, balancing length how much they gave? 20 centimeters. So L is 20 centimeters. What is 100 minus L? 100 minus L is equal to 100 minus 20. 80 centimeters. If you have written L1. Okay, this is nothing but in first case given. In second case what they give? Case 2. What they give means in left gap P. In right gap 10 ohm is connected in with S. 10 ohm is connected in parallel with S. Then what is the resultant resistance of this one? This is nothing but resultant resistance of two resistors when those resistors are connected in parallel. So this combination you will get one new resistance. That value we are taking it as Rp. What is Rp here? Rp is equal to, did you remember the formula? When two resistors connected in parallel, what is the formula? 1 by Rp is equal to 1 by R1 plus 1 by R2. Did you remember this formula? According to this formula you will get Rp is equal to R1 R2 by R1 plus R2. Here R1 is 10 ohm, R2 is S. Therefore, how you will get means 10 into S by 10 plus S. This one right gap resistance. In case 1, P is equal to we should find, S is equal to we should find. Left gap, right gap they connected. So in left gap whenever these two are connected, balancing length is 20 centimeters. The L2 is 80 centimeters. Now for S they connected in parallel. In left gap P only there, P is not changed. But in right gap new resistance will come because two resistors are combined in parallel. The new resistance value is Rp. Now what is the balancing length? L1 is equal to L is equal to 50 centimeters. Now L2 is equal to 100 minus L. That is nothing but 100 minus 50 how much? That is also 50 centimeter. This is nothing but given. After given that, what we have to find? We have to find PMDS. Next you have to think about formula. Only one formula, that is nothing but we know that. What is the formula? X by R is equal to L by 100 minus N. Otherwise, P by Q is equal to R by S. But meter bridge, we have written there X by R is equal to L by 100 minus L or L1 by L. Anything you can take. Here X means what was X in the meter bridge experiment? Left gap resistance. R means right gap resistance. In case 1, what is the left gap resistance? In case 1, P. Therefore, in place of X, P. In place of R, right gap resistance. That is nothing but S. So P by S is equal to L1 by L. L1 is 20. L2 is 80. How much? 1 by 4. P by S is equal to 1 by 4. Call it as equation number 1. Now go for case 2. In case 2, again we have to apply same formula. We know that X by R is equal to L by 100 minus L or L1 by L. Again, X means left gap resistance, R means right gap resistance. In second case, in left gap resistance how much? P. Therefore, P by, in right gap resistance how much resistance we are taking? Because there are two resistors are there. Therefore, we have taken RP. So RP, directly also you can write this value. That is your wish. So RP. And what is the balancing length? In second case, L1 is 50. 50 by 50. So P by, what is RP? 10S by 10 plus S is equal to 1. So this one is going for numerator. P into 10 plus S by 10S is equal to 1. Okay. So in this P by S from equation number 1, what we can write? P by S is equal to 1 by 4 here. So in place of this P by S, what we can write? 1 by 4. If you have taken P by S 1 by 4, means remaining what is there? 10 plus S by 10 is equal to 1. So since P by S is equal to 1 by 4 from equation number 1. Now we have to solve this one. This will be coming under mathematics. So 10 plus S into 1. 10 plus S by 4 into 10. 40 is equal to 1. 10 plus S is equal to, this 40 will go this side. So 10 plus S is equal to 40 into 1. 40, and S is equal to 40 minus 10. That is nothing but 30. What is S here? Resistance in right gap. Therefore, what is the unit? 30 ohms. Now you got yes. Now we have to find, what do you have to find? S and P. So how you will get P means either you can. So previous video got stuck at 33 minutes because of some technical problem. Now I am going to solve remaining part. So we got S is equal to 30 ohms in that problem. Now we have to find resistance P. So we got equation number 1. So from equation number 1, P by S is equal to 1 by 4. S value how much we got? 30 ohms. P by 30 is equal to 1 by 4. And P is equal to 30 by 4, that is nothing but 7.5 ohms. So this is the problem on meter bridge. We found P and S. So our next concept is, and last concept is potentiometer. Last concept means in the electricity, current electricity lesson. This is the last concept, potentiometer. So up to now we discussed about meter bridge. So what is the use of meter bridge means? We will find resistance, unknown resistance of the given wire and specific resistance or resistivity of the given wire. Now what is the use of potentiometer? So by using potentiometer we can find EMF of a given cell. So So EMF of a given cell, electromotive force. Already we defined this one in previous videos. Next one, to compare the EMFs of two cells. To compare the EMFs of two cells. So two cells they will give. One is having EMF E1, another one is having EMF E2. Which is more, which is less? We will compare. So next one, last one. To find the internal resistance. To find the internal resistance. To find the internal resistance of a cell. So by using potentiometer. All these three are uses of potentiometer. You will be having in your lab these two. We will compare EMFs of two cells and we will find the internal resistance of a given cell. One cell they will give, we are going to find by using potentiometer. So what is the construction of potentiometer and principle of potentiometer? We are going to see. In meter bridge also we will be having principle. In this also we will be having principle. So now see the potentiometer. So this is potentiometer. So which is having 1 meter scale here. Below this one 4 wires are there, you can see. So this is 1 wire of each 1 meter. This is another wire. So total length of this potentiometer wire is 1, 2, 3, 4. 4 into 1 means 4 meters. Otherwise 400 centimeters. So these are nothing but 2 ends. So this one we will call it as A. Another one we will call it as B. Otherwise P, Q. Between these 2 ends we will add, we will attach or we will connect battery to provide the current flowing through this potentiometer wire, and this is the jockey we are going to use. So in meter bridge also we said move the jockey on the wire unless you got the null deflection in the galvanometer. Same like that. So in this also you have to move this jockey on this wire till you get the null deflection in the galvanometer. Where we will connect galvanometer. So for what we are going to connect galvanometer, we will explain now. Now I am going to draw this one on the board, providing battery which is connected between A and B or P and Q. So meter bridge we saw. Similarly, we are going to do potentiometer. So now I am drawing here. This is one point A, one wire. So below this, another wire. 3, 4. So in our potentiometer they have shown 4 wires. I am drawing here 6 wires. Now for these two we have to connect. Otherwise current will be coming up here. It is going to stop here. So to connect this one we are going to use one metal strip. This is another metal strip. Another metal strip. Now see. So these are this is nothing but point B. This is nothing but point B. Now what is the length of this potentiometer now? 1, 2, 3, 4, 5, 6. 6 into 1, 6 meters or 600 centimeters. To provide the current, we are going to connect this one for battery. So provided by key with some rheostat. Rheostat means variable resistance. So this is nothing but we are providing steady current through the potentiometer wire by connecting a battery with key. Whenever we are closing the key, current is going to pass. Okay, in this we are going to show metal strip. You can see this is nothing but a metal strip. Between these 2 wires, one metal strip is going to be connected. That one. So this is potentiometer. Now what is the principle of potentiometer? What is the principle means? The potential difference between any 2 points. If you have taken one point P, if you have taken another point Q. So the potential difference between these 2 points. The potential difference between these 2 points VPQ is equal to or is directly proportional to length of this potentiometer wire. Length of this potentiometer wire means only from P to Q. Always potential difference between any 2 points of the uniform current carrying conductor is directly proportional to length of that portion of the potentiometer wire. Okay, total length is different. Total length is here 600 centimeters or 6 meters. But in which point you are taking between those 2 points, potential difference is always directly proportional to length of that portion of the potentiometer wire. Whenever we are removing this proportionality, we will write one constant. Vpq is equal to 5 into. In this one only, they will write very in similar way. For your convenience, in simple purpose. Why? Because here always we can't show P and Q. How they will write means. So E of means potential between 2 points, any 2 points. Here I have taken P and Q here. You can take anywhere. So potential difference for this length, for particular length, is always directly proportional to length of that portion of the wire. So this one they will write like this. So this one only they will say potential gradient of. Here phi is nothing but potential by length. Potential by length is giving potential gradient. This is the principle. How we will say this one means potential between any 2 points of the potentiometer wire is always directly proportional to length of that portion of the potentiometer wire. Okay. So this is nothing but principle. By using this principle, we are going to find comparison of EMFs of 2 cells and we are going to find internal resistance of 2 cells. But while drawing, so this is our textbook diagram. So in some books, in some reference books, they will give this potentiometer like this in simple way. Here AB is nothing but potentiometer. Instead of taking all these 6 wires, here I am taking, this is total 1 wire. So from here on we are going to connect for Rio star. Both are same only, but small difference is here instead of taking 6 wires, I am taking here 1 wire. This is also potentiometer. In some reference books, they will show like this. So in our textbook, they have given like this. So like this also you can draw, like this also you can draw. Both the diagrams I will show which is comfortable, which is easy for you. Like that you can draw. Okay. Now, first one we are going to see to compare EMFs of 2 cells. How we will compare EMFs of 2 cells? By using potentiometer. So what we have to take means, first we have to take EMF of one cell, that is nothing but E1. One cell we have to take, that cell EMF is E1. Another cell EMF is E2. So both the cells you have to connect for potentiometer. How we will connect means here. This is point A which is connected for positive terminal of the battery. There I am connecting one cell which is having EMF E1. So another cell I am connecting to A only. So this EMF is E2. So for this first cell, I am connecting one key K1. For the second cell, I am connecting one key K2. Okay. So now both are connecting. One galvanometer. And second end of the galvanometer is going to connect with jockey J. Jockey J. Already we have shown jockey J how it would be. This is nothing but from this galvanometer G we are going to connect with jockey J. What this jockey J will do means we have to move this jockey on potentiometer wire till you are getting the null deflection within the galvanometer. Null deflection means zero deflection within the galvanometer. Okay, this is nothing but process of working. So this is nothing but construction of potentiometer to compare EMFs of 2 cells. So what we connected? 2 cells we connected, both the positive terminals we connected for point A, where we are going to connect the positive terminal of the potentiometer main battery. And second ends we are connecting with keys through a galvanometer, and the last end we connected for jockey. Now what you have to do? What you have to do means, so it is producing, this is called, we will call primary circuit. Primary circuit will send some amount of constant current for this one. That one, what is that phi in the principle? We are going to discuss in competitive. Now we are not giving there. Why? Because for PU this is enough. Now see here. So some amount of current is passing through this potentiometer. This current is going here also, and this cell is sending some amount of current. So this current we are going to make it as 0 within the within the galvanometer. How we will make? We will see. First close key K1. Whenever we are closing, current is going to pass through this circuit also, isn't it? Now move this jockey on this potentiometer wire from A to B. Somewhere you will get null deflection within the galvanometer. Where you got null deflection? Let us assume somewhere at point C you got here null deflection. Then find the length from A to C. Let us assume from A to this point, how much? 1 meter. From here to here, 50 centimeters. The total length of this potentiometer wire is how much? 150 centimeters. 150 centimeters is the balancing length whenever cell E1 is connected. Understood? So close key K1, then E2 is not working. Only this cell only will be working. Close key K1 and move the jockey on the potentiometer wire till you got the null deflection within the galvanometer. Then you will get the first balancing length. According to principle, what is the principle of potentiometer? So E is directly proportional to L. Therefore, which cell we use here? E1. Therefore, E1 is directly proportional to L1. Call it as equation number 1. This is according to principle of potentiometer we wrote. E1 is directly proportional to L1. So here L1 is the balancing length whenever E1 is in the circuit. Next, now open this key K1, close this key K2. Now we open key K1, close key K2. Again, what you have to do means move the jockey on the potentiometer wire till you got the null deflection within the galvanometer. Somewhere you got at point D. Again you can measure length. This length is nothing but second balancing length. At the time E2 is directly proportional to L. Now how we will compare means equation 1 by 2. That is nothing but E1 by E2 is equal to L1 by L. You know L1 and L2. You will get some value here. Then which is more, which is less, you will be getting. So this is nothing but how to compare two cells of EMF, two EMFs of two cells EMF. How to compare EMFs of two cells. First what we did, we connected those two cells with keys K1 and K2. First we close the key K1 and move the jockey on the potentiometer wire till you got the null deflection. Again open key K1 and close key K2. Move the jockey on the potentiometer wire till you got the null deflection. Both the values we are taking according to principle of potentiometer. This is the principle of potentiometer. According to this we have taken equation 1 by 2. You will be getting very simple. So in reference books, how they will show this diagram. This is according to your textbook. In your textbook also 1, 2, 3 numbers they will give. I have taken directly key K1 and K2. Like this also you can draw, no problem. In reference books I have told you now first one. So this is battery with key. This is nothing but VS2. So this is A. Here AB is the potentiometer. This is called primary circuit. In secondary circuit, they will connect here. This is nothing but E1. This is nothing but E2. K1, K2. So this is galvanometer. This is nothing but jockey. So first press key K1, open key K2, then move the jockey on the potentiometer wire. You will get balance. Again open key K1, press key K2, again move the jockey on the potentiometer wire, you will get null deflection. Like this also you can draw, both will be same one. Okay. So now we will see second one, to find the internal resistance of a given cell. This one also they may ask for 3 marks question for you, very very important derivation. For this one also we are going to take same potentiometer. We are finding internal resistance of a given cell. One battery or cell they will give. For that cell, we are going to find what is its internal resistance. For that, we should connect one cell of EMF E. Okay, so for this, we are going to connect one resistance box, known resistance box with one key. So these two we are going to connect with a galvanometer. The second end is going to connect with a job. Okay, so resistance box, known resistance box, key. See here, key I didn't keep dot means that key is open. If I kept dot means the key is closed. So the dot is giving that much difference. We should be careful whenever we are using this circuit. Okay. Now we are going to find internal resistance of the given cell. What is the process? What is the process means again same. What we will do? Open the key K. Now we open this one. In this current is not passing. Open the key K and move the jockey on the potentiometer wire till you got the null deflection. Somewhere you will get balancing length. According to principle of potentiometer, so E is directly proportional to L, where L is balancing length. Whenever a cell of EMF E is connected within the circuit, key is open. Now what you have to do means close the key. Whenever you are closing the key, current is passing in battery, in cell, and within this resistance also. Here you are applying some amount of resistance, known resistance. You can apply 10 ohms, 5 ohms, like that. In laboratory, we will see whenever, how much resistance you are going to apply. So here you are applying some amount of resistance within this resistance box. Now you close the key. Now again move this jockey on the potentiometer wire to get the null deflection. So whenever we are getting with battery, that is L1, first balancing. Whenever we are using resistance box by closing the key, that balancing length is nothing but L2. What we have to write in LHS, that is very, very important. Previously we wrote EMF of a given cell. Why? Because there is no current within this resistance. Current is flowing directly within the cell. And within the galvanometer it is going to be 0. Therefore, we are writing potential difference between 2 points is going to become EMF of the given cell. EMF definition, when we discussed, we have to recall once. EMF is nothing but the potential difference between two ends of the cell whenever it is not drawing any current. Current is going to become 0. Whenever it is drawing some amount of current, it is not EMF, it is called potential difference. Now V is directly proportional to L. Why we wrote E here, why we wrote V here, you should have clarity. Why? Because here EMF is nothing but it is not drawing any current here within the resistance. Therefore we are calling it as EMF. Whenever we are taking resistance here, within this resistance also some amount of current is passing. Therefore we should not write this one as EMF. Understood? To see the concept of EMF of a cell after completion of this video once or by pausing this video here, then you will be getting clarity why we wrote here E and V. Now equation 1 by 2, we are getting E by V is equal to L1 by L. So current is equation number 3. Now what is this voltage, what is this EMF relation? Whenever some amount of current is passing through battery. We will show this one here once. It is having external resistance R. It is having internal resistance small r. Some amount of current is passing through this. So EMF is E. How much amount of current according to Ohm's law? E by resistance. Resistance means R plus R. This one I gave already whenever we discussed about cell which is having internal resistance. Now this formula we are going to apply here to get E by V ratio. How we will get means, write this, we know that I is equal to E by R plus R, or E is equal to I into R plus R. Then E is equal to IR plus I R. So how we will write? Otherwise take common R here. You will be getting directly if you have taken R. So IR is equal to 1 plus what you are going to write? R by R. According to Ohm's law, we get now voltage across this resistance. How much you will get? Voltage across this resistance. V is equal to IR. Therefore, in place of IR, we can write V. Isn't it? Now E by V is equal to 1 plus R by R. Call it as equation number 4. Now from this 3 and 4. So from equation number 3, E by V is equal to L1 by L2. From equation number 4, E by V is equal to 1 plus R by R. Then from 3 and 4, what we can write? 1 plus R by R is equal to L1 by L2. What we have to find? We have to find internal resistance of given cell. Send this one that side. R by R is equal to L1 by L2 minus 1. Small r is equal to capital R into L1 by L2 minus 1. This is the final formula. Otherwise, we can take this one as L1 minus L2 by L2. So in this capital R is no resistance what we applied within this resistance box. What is L1? Balancing length whenever key K is opened. L2 is balancing length whenever key K is closed. These three factors we came to know. Therefore, we can find internal resistance of the given cell. Okay. Now practice one or two problems from your NCERT textbook. Example problems are backside. They will give some problems. You can practice simple. First equation E1 by E2 is equal to L1 by internal resistance capital R into L1 minus L2 by L2. So for this, how they will ask means two cells they connected. First time balancing length, second time balancing length they will give. What is how we will compare means just L1 by L2. So first balancing length 120 centimeters, second balancing length 500 centimeters. So 120 by 500 centimeters. If you substitute, you will be getting comparison. In this, they will give resistance, balancing length, second balancing length. So then how to find internal resistance? If you remember these two formulas, you can solve the problems on these two. Okay.